So we're talking about imaginary numbers today. And imaginary numbers came up from the quadratics that we've been working with. What happened is when they were doing the quadratic formula, or when they were looking at those graphs, we know graphically the solution is where we cross the x-axis. And we saw a situation where we didn't hit the x-axis at all. Or, if we do quadratic formula, what if during the quadratic formula, under the square root piece, you get a negative number? So they decided to try and answer that question. What happens if you're taking the square root of a negative number? We have not talked about that yet or seen that. What happens if you're taking the square root of a negative number? And that was actually a pretty complicated question for them to answer. It was not easy for them to come up with a solution to that. Does everyone have the objective written down before I scroll down? Okay. So let's look at square root of negative 4. Square root of negative 4. When we're square rooting this, we know square root really means what multiplied by itself equals that number under the square root. So we want two numbers that are exactly the same to multiply to be negative 4. So when we try to figure that out, what's the closest we can come to that requirement?
2 times 2.
Okay.
Negative
2 times negative 2. Those are pretty close to being exactly the same, but they're not quite exactly the same. This should have been, so needs to be, exactly the same.
It's 61.
Okay, those are supposed to be exactly the same, and they're not.
Mine says 946. This is 61.
This is 951.
So they need to be exactly the same, and they're not. They decided to come up with a solution to that by coming up with a new idea, and they call this idea an imaginary number. They said, if we write this as 2i times 2i, I being our imaginary number, which we don't have the definition for yet, so I can't show you why that works for like 2 minutes. Okay? So they said, well, that's exactly the same, so it fits our requirement of having a perfect square. So square rooting means you can multiply something by itself that's exactly the same. So in order for us to understand why that worked, we need to know what is an imaginary number. What did they define an imaginary number to be? So they defined an imaginary number They called it I. They could have called it anything they wanted to. Emily. They could have called it anything they wanted to. They could have said, we're going to say this is Bob. But they picked I because they thought it fit logically calling them imaginary numbers.
Kevin.
Okay? We could have called it Kevin.
I'm going to call
Okay.
it Kevin.
We could have called it Julio. We could really call it anything we want to. But they picked I, and they said it's defined to be the square root of negative 1. So let's see if that works up above. We said 2i times 2i is supposed to equal negative 4. So 2, we said I is -1, times 2, we just defined I to be -1. So if we multiply that out, we have 2 times 2 is 4. Square root of I times square root of I is square root of -1. Sorry, not square root of I. Square root of -1 times square root of -1 is square root of -1 squared. And what happens when we cancel out a square root in a, or what happens when we have a square root in a squared? I just said the answer.
It cancels out.
Cancels out.
Oh,
So we have 4 times -1, which is -4. So did that give us the number under the square root?
Yep.
Yes, it did. So that's why they defined it that way, because it fit the definition of the square root.
No, I'm just looking.
Oh, okay.
Isn't this fun stuff, you guys?
Oh my
That's your
gosh,
number?
this is so fun.
Can you believe this? What the heck?
It's pretty
This
crazy.
is
pretty
the
cool.
imaginary number, right? So they're not confused or anything. I'm confused.
Oh, I'm sure they're confused.
No.
They
Oh,
don't,
I-
they don't,
no,
they
she's a
don't
great
shout out
teacher.
and let you know, they just kind of think about it and work on it.
It'll take a couple of times of seeing it before we're not confused.
I trade and have your class and you have my class. Because look at how they're doing so well.
They are being pretty good today.
We deserve a treat today.
I do not have any treats with me, I'm sorry.
Yeah. Wow.
Okay? Okay, so let's refocus. I need everyone's attention back up front. A second definition we're going to need is we're going to need to know what does I squared equal as well. It's going to be used when we end up doing some multiplication. So we know I is square root of -1. And if I square it, again, what happens with the squared and the square root? Cancels out. So now we know I squared equals -1. So this and this are the two important definitions we're going to need in order to do our homework today. So actually understanding what an imaginary number is pretty hard. Sometimes I still feel like I don't really understand exactly what imaginary numbers are. But working with them is pretty easy. So let's look at an example where we add or subtract our imaginary numbers, and it's a pretty simple process when we actually go to do stuff with imaginary numbers. So we have 3 minus 5i. They put it in parentheses because they're saying this is one entire imaginary number. Plus 2 plus 7i. And the process is pretty easy. It's a process you've actually used already. If we're adding these together, we are combining like terms. Okay? That's a pretty easy process that you've learned in previous years. Thank you. So if I'm combining like terms, what's my like term with 3? 2. Add those together, we have 5. Yep, we add because it's a plus sign in the middle.
Oh, I thought it was.
The 5 is negative, but it's not attached to the 3. The negative sign is attached to the 5. Then we combine negative 5i and 7i. So negative 5i plus 7i, 2i. Positive 2i. So plus 2i. And we are done with that problem. Yep. So like I said,
Is that what the homework's going to be like?
not the entire assignment, no, but the first 4 problems. They're actually the first 8 are a combination of adding, subtracting, and multiplying. Yep, the 2i is your imaginary piece. Again, so really it's like you had 5 times the square root of a -1 and 7 times the square root of a -1. And they just called that square root of a negative 1I, so that it was simpler to work with. Okay, so let's do one where we're subtracting. Let's do one where we're subtracting. This is a little bit more difficult, but not much, and we've seen this when we did adding and subtracting polynomials. The negative sign does affect everything behind it. So what's really in between that negative sign and the starting parenthesis of the second number? Positive 1. We can put a 1 there. Negative times a positive will really just make it a negative 1 overall. We can put a 1 there and distribute it in. The negative sign will change everything behind it. So we'll have 3i, that just comes down. I don't need the parentheses anymore because there's nothing out front to affect it or change it. Negative 1 times negative 5 is positive 5. Negative 1 times positive 4 is negative 4i. And now we just combine like terms again. So I want you guys to finish this problem. Combine like terms and I'll come check. Okay, can I have your attention back up front?
Taking another time.
Guys, refocus. We're ready. Jaren, what did your group get for your answer?
5 minus 1i.
5 minus 1i.
Or we could just put I, but that's not
You could just put 5 minus I.
That's not cool.
Some people had negative 1i plus 5. That is technically correct. Again, the normal order, though, this time is to put the real part first, the 5 first, and the I second. So I won't mark you anything wrong if you put negative 1i plus 5. It's just going to drive me nuts because that's not the normal way to write it. But still right. Okay, so we still need some other operations with our imaginary numbers. Which math operation is this? What are we doing in this problem? Multiplying. How do we know we're multiplying in this problem? The parentheses are right next to each other. If the parentheses are next to each other, you are multiplying. Instead of having a plus sign or a minus sign in between, we're multiplying. How do we normally multiply something that has 2 parentheses? Distribute. So we are going to distribute, or rainbow method, or FOIL. It does not matter what name you use. We are going to distribute. When we distribute, we do the first number in this parenthesis, 5, times everything in the other parenthesis. Then we go back to the parenthesis and use 2i times everything. So we'll have 5 times negative 3. So I'm going to write out this extra step that you wouldn't write in your notes. I'm putting that little squiggle to say this is an extra step. So we would do 5 times negative 3. Most of the time you're just going to do that step in your head and you're not going to actually write out that you're multiplying 5 times negative 3. We multiply that together, get negative 15. Then we have 5 times I. What happens when you multiply a number by a variable?
5i.
5i. You just write them next to each other. So positive, so plus 5i. Oh, and my first period did ask, why am I writing my i's kind of funny? If we did an I like this, okay, it kind of looks like a 1 if you're not careful. So they usually do a fancy I. I do the kind of backwards JI, but on the assignment it's more italicized than like this. It's going to look more like that, but this can be mistaken for a 2 if I'm not careful. So I usually do this when I'm writing by hand, but it really should be italicized if you're actually doing this. So we need to keep multiplying. 2i times negative 3 is negative 6i. Guys, Austin. Negative 6i, and then we multiply 2i times I, so plus 2i squared. So this is why we learned what I squared equals. If we go back to the start of our notes, what do we know I squared equals? Negative 1, okay? A negative 1. That means I can replace I squared with negative 1. I can't replace I can only replace I squared. So we replace I squared with negative 1. Because we know that's what I squared equals. So we do not replace the i's that don't have squared, only the I squareds. So we have negative 15 plus, we'll just rewrite the whole thing, 5i minus 6i plus 2, and instead of writing I squared, that whole thing changes to be negative 1. And it's 2 times negative 1 because that's 2 times I squared. So most of that problem didn't change. We can do some combining in a minute, but first we wanted to get rid of that I squared. Anytime we see I squared now, we should get rid of it and replace it with negative 1. So now I just have to simplify this and combine my like terms. Now it's basically our addition problem after we get rid of that little multiplication part. So here we can multiply 2 times negative 1 together. Order of operations says we multiply before we add. So we get negative 15 plus 5i minus 6i minus 2. And you may get to the point where you could do this in a few less steps, but I've been writing out every single possible step you could write. And then we combine. What would negative 15 combine with?
Wait, no, 2.
Negative 2. Gives me negative
17.
17. 5i minus 6i.
Negative 1i.
Negative 1i. Or just negative I. You could write it either way. Once you combine those like terms, we're done.
Is that what our homework's going to look like?
That'll be the first 8 problems. Then I wanted to show how to simplify the quadratic all the way. We talked about it a little bit in the homework. But let's do one more example problem where we're going to use quadratic formula to solve. And this time we're actually going to get an imaginary number while we're solving our quadratic.
I like imaginary numbers.
Good. This part is pretty straightforward. Okay, I'm going to change this a little bit really quick though. So the first 8 problems are just straight imaginary numbers where the last 8 problems are reviewing again how to solve a quadratic. I have 1 completing the square problem, 1 factoring problem, and then 6 quadratic formula problems. So we have 3x squared plus 4x plus 8 equals 0. If I just give you that and tell you to solve, we should be able to say, okay, that's squared. Squared means I have a quadratic. And then last time we wrote out the notes of the 5 different ways. Graphing, square roots, factoring, completing the square, and quadratic formula. The ones you use most often will be factoring and quadratic formula. Those are the ones that are used most often when you're just given a general quadratic and told to solve. We're specifically going to be using quadratic formula in this. So we have to find A, B, and C. And they go in order. So a is always the number in front of x squared. So Brett, will you please tell us what a is? 3. B is always the number in front of x. So Steve, will you tell me what b is? We took a from here. We're going to just keep traveling along. So what comes next? 4x, but we're just going to use the 4 only. And Desiree, what is c? 8. Next one in the line is 8. So now we go plug it into the full quadratic formula. I've written it a couple of different times, so you have it a lot of different places in your notes. So we started with negative b. We said b was 4. Plus or minus the square root of b squared. What number do I put here if this is supposed to be b? 4. Minus 4ac all over 2a. So now we simplify. We had to simplify the stuff before the plus or minus. We had to simplify the stuff under the square root. We had to simplify the denominator. So we have negative 4 out front, plus or minus. The bottom will be square root, or will be 6. And then we just have to figure out the square root. The square root's the hardest part to simplify. The first part and the bottom part are pretty easy. We're just multiplying. This part, we have to go through an entire process. First, we square this number. What is 4 squared? 16. I'm just going to write the work a little bit below, just so we don't have to keep writing the full quadratic formula over and over again. Then we multiply negative 4 times 3. Negative 12. And then the 8 is still there. So next we multiply the negative 12 times 8. Negative 96. And if we subtract, we get 16 minus 96 is negative 80. So we've practiced up to that point a couple of times. We did last assignment and the assignment before. So we've practiced up to that point. But now we're going to take this simplification a step further. So now I'm going to focus on the square root. And I'm going to simplify square root of negative 80. So I'm going to simplify just that piece. So if we simplify something like this, how do I simplify a radical? What process did we use that we learned at the very beginning of this entire year? Factor tree. Good. Factor tree. So ignore the negative sign for now. We're going to talk about that at the end. Just 80. What are some things that multiply to be 80? 40 times 2, 2 times 4, 20 times 4. Again, we're ignoring the negative sign. I'm just saying 80. So 40 times 2, 40 would be 8 times 5. 8 would be 4 times 2. And 4 would be 2 times 2. So we've done our entire factor tree. We write it out under the square root. So we have square root. I'm going to put the negative sign here. And then we have 2 times 2 times 2 times 2 times 5. What size groups are we looking for? Because the original was negative 80. So I just brought that negative sign down now. So we have two groups of 2, but we're also going to have to do something with this negative sign. What number is really here out front with that negative sign? If we're multiplying, it's 1. When we're adding and subtracting, it's usually 0. So 1. What do we know about the square root of negative 1? What do we know about square root of -1? What does that equal? I. It's the new thing we learned today. So this piece comes out front and becomes I. The rest act normally. We know one dies, one makes it out. One dies, one makes it out. So we would get 2 times 2 times I, square root symbol, 5. We got an I because there is a negative. The rest we got because we just did our old school simplification using a factor tree. So we would get 4I square root 5. So now we need to go back to our entire answer and put that in. We know negative square root of 80, that entire thing became 4I square root 5. So we get -4 plus or minus 4I square root 5 all over 6. Now, we do have to check one last thing when we're simplifying these square roots. We look at these 3 numbers, and if they have something that divides into all 3, we do that division. What would divide into a 4, a 4, and a 6? A 2. So I'm going to divide all of them by 2. It has to be the same thing that you're dividing into all of them. So our final answer will be -2 plus or minus 2I square root 5 all over 3. So it can be, I think it's harder to simplify this quadratic formula than it is to use the quadratic formula. There's a lot more going on. So we have about 10 minutes to start on our assignment.